Okay, today's lesson is lesson 7, which is constant rate of change. Um, in the past, we've used ratio tables and graphs, line graphs, and um, proportions and equivalent ratios, all to determine if something was proportional, and then if it was proportional, to find that missing value. Constant rate of change talks a little bit about the relationship between those numbers within that ratio table, and also those points that you would find on that line graph. So that's kind of what you're going to be doing today. We're going to be looking at those values and how they relate to each other. Now, this lesson, constant rate of change, is very similar to the next lesson that we're going to do, slope. So normally I don't start with this page, but today I'm going to, just for this little section of the vocabulary. A rate of change is a rate that describes how one quantity changes in relationship to the other. Now, in a linear relationship, and we know that a linear relationship is a proportional relationship as long as it goes to the origin. But in a linear, and this is all linear relationships, the rate of change between any two quantities is the same. A linear relationship then has a constant rate of change. So this doesn't necessarily have to be a proportional relationship. As long as it's a line, it's going to have a constant rate of change. If it's got a line that's a constant rate of change and then goes to the origin, it is considered a proportional relationship. So that's how they're related. Okay. So I'm going to skip forward. So essentially, this lesson today, in the past, we've always talked about proportional relationships having that multiplicative relationship. We've talked a little bit about adding, and some of you have alluded to that, but I've kind of stepped away from that because I knew that this was coming. When you're talking about a constant rate, and I'm just going to put CR for constant rate. You should write it out. This little mouse here is not friendly to work with. When you're talking about a constant rate, we're going to be talking about the additive relationship. Okay? The additive relationship. Now, it takes me 10 times longer to write with this. It's easier to do cursive. Okay, so it's that additive relationship. So if you look at this first example, we're going to use a table, a ratio table, to determine if it has a constant rate of change. So this is now where you're going to be looking at that adding every time instead of the multiplying, okay? So what did I do to 5 to get it to be 10? I added 5. What did I do to 40 to get it to be 8? I added 40. What did I do to 10 to get it to be 15? I added 5. What did I do to 15 to get it to be 20? I added 5. What did I do to 80 to get it to be 120? 40. What did I add to 120 to get it to be 160? 40. So your constant rate of change then, so the constant rate of change is that it's the change, and you should write this down because this is kind of your formula. It's the change in, it's not going to let me write in there. I have to go underneath. In y over your change in x. Okay, now we've already talked about this when we were graphing proportional relationships. That's why that really needed to come first. Your value here, your input, is your x. Your value here is your y. So my change in y is $40, and my change in x is 5 cars. Okay, that's your constant rate of change. Now, you can use that then to determine your unit rate, right? you can determine your unit rate. You would take $40 divided by 5 cars gives you a unit rate of $8 in one car. That's your unit rate. So you take that constant rate of change and you simplify it to lowest terms and get a unit rate. Now sometimes when you simplify it, you're not going to get a unit rate because there are times that your value is not going to be in lowest terms. Now, your book does something that I don't necessarily agree, or not your book, this book does something I don't necessarily agree with completely, in that they will allow you to put a decimal within this constant rate of change. And traditionally, it really should stay a fraction, and it should stay an improper fraction, or a fraction that's just in lowest terms. It doesn't have to be a unit rate unless I specifically ask you for a unit rate. So, that's just going to make it easier for you later, okay? No mixed numbers, no decimals when you're doing a constant rate of change. Okay, so look at problem A here. Okay. This constant rate of change, to determine this, you're just going to figure out what do I add to this to get to this. So what did I do to 30 to get it to be 60? I added 30. Okay. So what did I do to 60 to get it to be 90? I added 30. What did I do to 90 to get it to be 120? I added 30. Okay. And this is my x, my time. Distance is my y. What did I do to 290 to get it to be 580? I added 290. What did I do to 580 to get it to be 870? I added 290. And what did I do to 870 to get it to be 1,160? I added 290. So to determine your rate of change, your rate of change is going to equal your change in y over your change in x. This is y. My change in y is 290, and we label it miles, over my change in x, which is 30 minutes. Okay, that would be my rate of change. Now, if I asked you to calculate a unit rate, because it does say per minute, then you would change that so you'd get, this is worth a point by doing, when I do your assignment, this is going to be worth a point, determining that rate of change. And then to determine that unit rate, you would take 290 and you would divide it by 30. This is what we've been doing all along. It's nothing new. And when you do that, you're going to come out to, because they're asking for a unit rate, 9, and then it's going to be 0.66666 repeating. It's a repeating 6. So you usually would round to the nearest hundredth. So that would be 9.67 miles per minute. Miles per minute. Okay? So what I would like you to do is I would like you to pause the computer and do B on your own. Pause the computer and do B. Okay, so your constant rate of change, and I'm going to put it over here so I have more room. My constant rate of change is my change in y over my change in x. This is x, this is y. Okay? And it says students per school bus. So you know that this is y then. Okay? So my change in y, 144 to 216, 216 to 288, 288 to 360, you need to subtract. 360 minus 288, you get 72. 288 to 216, you get 72. 216 to 144, you get 72. Now, when you're given a ratio table, I'm going to expect that you are going to show this work because that's Mrs. Shaw, and I want to know that I can see what you're doing. You can't just write an answer for me. What did I do to 5 to get it to be 4, 4 to get it to be 3, 3 to get it to be 2? For all of these, I added 1. Okay? So my constant rate of change is my change in y, which is 72, and 72 students over 1 is my change in x bus. That would be my constant rate of change. My unit rate then would be 72 students per bus. $72 students per bus. Okay, if you got that right, you can move on. If not, you should rewatch because now we're going to go on to graphing. Okay. You could also find constant rate of change by using a graph, and this is actually most often what you are going to do probably when you're talking about a constant rate. And you did this in 6th grade math. I know you did because I've talked to some of the students that have said that you've done this. You used lines and determined rate, constant rate, using ratio or using triangles like this. Okay? So you can do this in multiple ways. Okay? You can count, or you can do subtraction, which is the same thing we've been doing. And so you could take these points and put them in a ratio table. But what you have to do is you have to find these points, because the points that they give you, or any points that you find, because sometimes they won't give you points, you can look at this and you can determine a constant rate of change. All you need to do is find your points and determine a difference. So you really only have to pick any 2 points. And essentially you're going to take a y minus y over x minus x, making sure that you stay and start with the same point. Start and end with the same point for y, start and end with the same point for x. That's important. Okay? So that change in y over that change in x is that constant rate of change. Okay? So, personally, I start from top and go down to bottom. I tend to start at the very top, the toppest most point I can get, and go down to the next most point. That just, for me, is what I typically do. Your book here started at the bottom, top 2 points. You could do either or. But your best bet is to start from the top and go to the bottom, because you're going to be subtracting. And when you subtract, if you go bottom to top, you're going to get a negative number. So it's easier just to stay away from that negative numbers and go from top to bottom. So I'm going to do my change in y, my y, this is an ordered pair, you should know this, is x, comma, y. So the second number is your y. So I have to do 180, because that's my y, right here, 180, minus my second y, 120. Then once I have my y's done, I go to the same point, my same starting point, and I go to my x. I have a 3, and then my next x is a 2. And then you subtract those. So 180 minus 120 is 60 over 3 minus 2 is 1. So my change in y or my change in x, you need to label these. 60 is what? What is my y? 60 is miles. And what is my x? Hours. That also happens to be my unit rate because it is over 1. So you don't have to do anything to make it a unit rate. So it's 60 miles in 1 hour. Okay? Okay. So we're going to jump down. Well, no, we can do number 3, I think. Let's look at number 3. Number 3 says, because this now isn't visual, it just gives you 2 points. It says, if I have a point 00 and a point 160, what does that represent? In this graph, 00 means, this is important actually, you really should know how to do this because this is going to be, you're going to have to assess, this is going to be on assessment. That 00 means that you're traveling at 0 miles in 0 hours. And we've kind of talked a little bit about stuff like this before. 160 means that you're traveling at 60 miles in 1 hour. Okay? 0 miles, 0 hours, 60 miles, 1 hour. That also means because it's 00, it's a proportional relationship. Okay, so I want you to pause your computer and I would like you to do C for me. Pause your computer and I would like you to do C. Okay, for C, you're going to determine your constant rate of change. So again, I'm going to start at my top because that's what I like to do. So it's my y minus my y over my x minus my x. And I would like you to write out that formula. Okay? So my y minus my y is 90 minus 60 over, and then I got to go back to my x, 3 minus 2, which equals 90 minus 60 is 30 over 1. Then I have to label it. My 30 is my miles, because that's on my y-axis, over 1, which is hours. That's my constant rate. It's also my unit rate. Now the second part of your problem, D, asks you to tell me what 00 means. 00 means I traveled zero miles in 0 hours. And 130 says, ooh, I can't write very well with this. I travel .30 miles in 1 hour. And I'm going to do this too. Okay, that's what I would write for a sentence. And this should be in a sentence format. I'm going to erase this quick. And I'm going to show you that's what it would be. The point 00 represents traveling 0 miles in 0 hours. The point 130 represents traveling 30 miles in 1 hour. And that would be then a nice, neat sentence. So you can pause your computer and write that down if you would like to. If you got those right, I would like you to move on. If not, I would like you to rewatch so that you know what you're doing. Okay? Okay. So what you have to do today, and this second one also, I'm sorry, the last problem, just to talk about it, you're comparing now two different stores. So pedal rentals and supercycles. And you're going to calculate their constant rate of change and tell me which one charges more per bicycle. So you calculate the constant rate of change for pedal rentals, which comes out, that comes out to be change in Y, $12 over your change in X, 1 hour. Okay, so that's pedal rentals. Supercycles, find those points. So right here's a point, and see what I mean when I say sometimes it won't be listed, and here's a point. This point is 16, comma 2, I think that is. And this point is 1, 8. Nope, sorry. I did that backwards. This is the y. Sorry, I wrote them as yx. This is your x. So we'll do it in that same format. 8 is my y, and x is 1. So y minus y over x minus x is going to be 16 minus 8 over 2 minus 1, which is 8 over 1. And 8 is my dollars, and 1 is my hour. So if you ask the question, which one, the question is which store charges more per bicycle, and explain, okay, this would be your answer. The cost at Pedal Rentals increases at $12 for every hour. The cost at Supercycle increases at $8 in every hour. So Pedal Rental charges more per hour to rent a bicycle. That would be your answer. And yes, you need to write that all out because of that explain. If it says explain, you need to explain. Okay, so what I would like you to do, you have a guided practice worksheet that you are going to receive. I would like you to do number 1. I guess I should put on my pen. I'd like you to do number 1. And I'd like you to do number 2. Okay? For number 1, you're going to do just above, you're going to calculate, you're going to point for calculating your constant rate of change for mealing savings, and 2 points for calculating, actually this would be 2 points for calculating meal savings, the work and then the answer, and make sure you label, and then 2 points also for Daniel's, the work and then the answer, and then you need to explain it in sentences just like we did up here. Okay? Then, number 2, you have to tell me what does those points mean, 0, 0, and 1, 10 on that graph. Okay? And I want you to have that done. And if you want to try, I'd like you to try number 3. You don't have to do 3, but I'd like you to try it because we are going to talk about 3. Okay? Okay.